So like I said, a quick demonstration of accumulating values and the impact of those values on the behavior of an object. All right, so let me see, just another quick demo here. So supposedly I have a video game, okay, and in that video game I would like to have I would like to show some sort of like a cockpit of an aircraft with, like, you know, some instruments over here and the steering wheel or something like that. So I'd like to show the horizon over there and all kinds of things that are happening down here on the ground, and I'd like to fly, right? So I'd like to control this you know, aircraft, which I see as a cockpit over here with set of instruments and the steering over here. So what I'd like to do is that I'd like to you know, have a user to be able to press buttons such as, you know, like for instance arrow keys on the keyboard, right? So I have a keyboard with arrows like this, which is very typical type of arrangement, for instance, right? So, you know, I can do up and down, and I can do left and right, and so these are basically the keys on my keyboard, right? So, and we started talking about objects accumulating the values. So it's interesting that the keys can be in two states, right? So the key, each single key of this, right, of the set of keys that I have, they can be up, right, depressed, or pressed down, up and down, right? So then the question is, if I press down on, let me try some kind of like you know, red indicator here, indicating that if I press, oops, oh, that was too much to use on this specific, oops, right? So if I press one of the keys and the key is pressed down, right? What happens if I press down on another key, right? So remember, one of the keys is already down, right? So one of the keys is already down. So for instance, the up arrow is already pressed by the user, and then another key is pressed, right? And then what happens is that this key is let go, right? So it's no longer pressed over here. So it can be depressed, and so forth. So it's basically, what I can do is, and then so all of these keys could control the aircraft differently. Perhaps it's unreasonable to require the user to let go all of the keys before the next key can be pressed, right? They're involved in the middle of playing the game. They just want to quick response of this vehicle to different combinations of keys. So there we go. So we have basically the input, the state of input here goes through basically a table like this, where we can say, you know, we can have the keys outline over here, right? So we can basically have all of our keys, which will be up, down, left, right, specify like this, and we can have their states, which may be, you know, pressed or depressed, and basically maybe we can use like a, you know, a separate indicator over here, right? And we can essentially describe then, with each possible combination of these keys, right, and their states, what should we do, right? So there could be, you know, like you know, descending, ascending, taking a turn, and all of the actions that we want to take, we would like to describe with a combination of keys. So instead of jumping to the software and writing some kind of, you know, if statement that analyzes the set of the key, and then else, you know, writing else if there is another condition which indicates another key combination. Instead, don't do this. First, just describe formally all possible key combinations and what you want to do. And then write your if-else statement by looking at your table of state and say, oh, what combination do I currently have, right? And then you can specify the transitions, what happens when you transition from one state to another, right? So with these 4 keys, the decision making can be very much involved in terms of how exactly the aircraft should respond to each combination to the combination of each of the key. So that's the example where I think it's an example for you to think about objects that accumulate the values. In my case, what I'm accumulating is the combination of keys, right? They can be accumulating. The user presses yet another key, another key, another key, and I can still deal with that situation because I taught my object, my input, my keyboard input, how to respond to each single combination and each single event with the combination of these keys. You can see that this is not very trivial. However, the state machine solves the problem because it can simplify, explain to you everything that, explain to you every single possibility, and for each single possibility, you then go ahead and write code which implements all desired types of state transitions, and in each single state you can then control your aircraft according to that, right? So even more things can be involved. For instance, when you have, you can have an autopilot involved, right? So at certain conditions, you can program your aircraft to basically ignore user actions because your autopilot tells you that it's unsafe or something like that. So even more things can be involved in this process, but that's what makes software interesting because we can program all kinds of interesting interactions. So here with keyboard input, that would be I think that the state diagram for possible inputs would greatly simplify, attempt to program that type of input from the user. All right, so that should do it for today, and I'll see you guys next week, and we'll continue with this agenda. So we're about like half through this presentation, but we're gonna finish it next week. So thank you.